Yes, we answer subscriber questions, and this is also about content creation and rendering. And the three questions we're going to address today are on this motherboard, the ASRock X670E Taichi. This is all about slots and storage and counting PCI Express resources from CPU and through the chipset. And when we start trying to figure where everything's at, for example, we have 2 slots, 4 M.2 connectors. How those are wired influences the questions you guys ask. So there's a short answer, but the video is about the longer answer. So we're going to have 3 questions we're going to deal with. The first question is going to be about, can you install a quad card? Yes, you can, but there's some caveats to that we're going to go through and outline in this video. Number 2, is there any X670E chipset that has 2 16-lane slots? No, and we'll cover that as we get into this so you understand resource allocations. And number 3, we've been asked to get a little bit more into some of the USB ports. So there's 2 issues to this. One about getting in the weeds, the other is going down a rabbit hole. We're going to try to avoid the rabbit hole, but we may get into the weeds on some of this. Because as we go down and look through and itemize, we're looking at the motherboard, the CPU, and the chipset. And as we try to compare the design versus the implementation, we have to understand where all that stuff is at, because all that matters when you guys want to plug stuff in for a purpose-built computer for content creation. All those resources matter. Now, we're on a consumer desktop motherboard. The machine in front of me is a high-end desktop. Above that is a workstation, and we're going to talk about some of the technology as it relates to this question that has trickled down from the server platform to the consumer desktop motherboard. So as it becomes relevant, I may show you this system inside, which is the high-end desktop we've always been a fan of in the past, which has kind of gone flat. And this is the Gigabyte TRX40 Designaire. Love it. But because of what's going on right now, it looks like we're going to have to go to a workstation. So that's a hard swallow for some to go from here on a consumer desktop motherboard to a workstation. But there's reasons for that, and it's all about resources. So let's go to the manual, and we're going to start with the block diagram, because I got to tell you, everything we do is about function. It's not about form. And as we look at the pictures on these motherboards, we can clearly see this is more about form. Everything's all covered up. We got to see stuff. We're going to go straight to page 3 for the contents. We're also going to look at the package contents, and I'll interject where appropriate. Okay, 2 things you need to do for those that have built, for those that have not built. When you get your parts, your computer, everything, put a camera on it, so when you open the package, you can compare what you've ordered to what you've received to make sure it's what it's supposed to be. Big topic, separate video. Number 2, you want to inventory your components to make sure everything you're supposed to have is there. Because just as we look at the motherboard, it's about give and take, because we can't use everything. There may be some resources in there that might keep you from using what you can. So inventory it and put a camera on it, make sure you get what you ordered. We're also going through the specifications. We'll go through the motherboard layout, and we're going to look at the I/O panel. And the block diagram is where a bulk of what we're going to be doing is going to give us the information we need. Now, as far as documentation, ASRock has done an amazing job. There were some things about this motherboard, and I've looked over it a bunch of times. I don't want to admit how many. But I was not that impressed with the motherboard at first. However, the more I have studied this motherboard, the more I begin to like it, and the more I begin to realize, wow. Things that stand out to me. Number 1, if you like to tinker, especially if you want to tinker with the BIOS, this is the motherboard you want to use based on what I see in the motherboard BIOS manual. We're going to get into that a little bit as it relates to 2 items. Number 2, if you like to do virtual machines because of the settings in the BIOS where you can virtualize, say, like the network interface, even though it's 2.5 gigabit, you can do that because of the settings in the BIOS. So those are 2 things that stand out to me. And there's another thing that stands out to me that I didn't get the first 3 times I looked at it, that I think when you see it, and it deals with, first of all, background. We've tested 14 M.2 NVMe heat sinks. We've tested 3 thermal pads. And we said at the time, we're going to test more in time, but we need to see some new designs. This motherboard is including a new design that I'm going to show you some information for the specs that hopefully will set a standard for what we're going to see coming out for PCI Express 5. Now, everything through the CPU is going to be PCI Express 5. Everything through these 2 chips, which make up the chipset, are going to be PCI Express 4 and below. Historically and typically, your lower powered or your lower priority devices are lower on the totem pole. So as we look at the diagram, once we get to that block, what we're going to look at and what we'll see is what's on the right, because of 3 numbers that we've always talked about. 2 numbers we get from AMD that we'll go through real quickly, and I'll show you. 4 different CPUs right now that have video on board. And because of that, 2 things we're looking for. 1, DisplayPort alternate mode. The CPU supports it. So we're going to be looking at the 7950. Number 2, we've got to look at PCI Express lanes. Okay. 2 numbers they give. the third number we come up with. Usable lanes and total lanes. Now, usable lanes, that's a pretty easy 1, 2, 3. When we look at the total lanes that AMD gives us, that's usually about what's going on with the USB ports. We can, I think, pretty well determine and ascertain how those ports are allocated on that back I/O panel. It's the other USB ports where it not only gets in the weeds, but it goes down a rabbit hole. So I'm going to try to avoid that. Now, that third number I mentioned is a total lane count, or what I call an absolute total lane count of what I think is the total. I have no basis for fact on that, just that looking at all these different manuals. I'm really pleased, amazed, and surprised at the documentation. MSI only has one feature in the BIOS that I'll save for the next MSI motherboard video we're going to do that does a little bit better on identification as it goes to the connectors. And I've had some feedback from one subscriber who's been sharing the information as we've been going back and forth how this works. You guys are amazing. I love my subscribers. Let's go to the motherboard layout, and we can kind of see where the plumbing is at. Pretty good indication of the I/O panel on the left. We've got 2 slots, PCIe 1, PCIe 2. We've got 4 M.2 connectors, _1, 3, and 4. And over here on the right, _2. And what gets interesting is when we start talking about whether it's going to relate to number 1 or number 2, about a fancy heatsink that's in the package. Now, other considerations, first of all, we have the primary chipset and we have the secondary chipset. Now, items on this I/O panel are either going to come out of the CPU, and some of the items will come out of that primary chipset, and then everything else will come through the secondary chipset. Okay, from the top down on the right side, we have the ATX 24-pin power, and this, let me zoom in on this a little bit more. That's for USB-C. Now, that particular port, on some motherboards, there's another power tap along this line, which we don't have, that gives us 60 watts. So first off, that's one thing we don't have. However, let me zoom back out on this motherboard. Over here on the left, we have a Thunderbolt 1 and a Thunderbolt 2 port. That's the USB 4. And we're going to cover that because it matters for lane allocations. So back over here on the right, as we go down the line, right here we have 4 SATA ports. How those are configured matters greatly. Because when we start talking about devices, we're looking at PCI Express 5, PCI Express 4. We're looking for fixed resources and shared resources. And when we're dealing with a consumer desktop motherboard, there's a lot of shared resources. So even though you have all this stuff, you can't use all this stuff. There's some give and take. Now, as we relate to these SATA ports, normally a SATA port, 1 SATA port, 1 lane. 4 SATA ports and 4 SATA ports. 4 SATA ports are through the motherboard chipset, or a chipset, let's say. My guess would have been the secondary, but you know, every motherboard's different. And then the other 4 that use lanes, these 4 through the motherboard chipset each use 1 lane. These other 4 through a separate chipset use chipset lanes, but the lane allocation is different. So I hope you guys will help you to understand that when we're looking at a motherboard and you ask a question, and I love answering them, this is absolutely fascinating who's on first, how some of this stuff goes. Because it's just, that's one of the reasons I like to look at the motherboard layout instead of the pictures, because there's some obfuscation when you're looking at all this form. I want to see the function, because if you can't plug everything in that you're trying to achieve, then it's like, man, what a PITA. I want to know that before instead of after the fact. And that's what we're trying to do, because think of this as an overview. This is not a review. This is just an overview. We've got all these motherboards you guys are asking questions about. So we're going to look at one, we're going to look at another one, look at another one. When we get through with all this stuff, as we get more questions about the X670E chipset, then we'll be able to give some kind of a overview of just the chipset. But right now it's an overview per motherboard, because there's some fascinating stuff going on. We look at the specs. The other aspect of this is how much does it cost, and then we try to compare as we talk about the technology. Are you better off on a consumer desktop motherboard, or are you better off based on resources for a workstation? And I've had some people talk to me about the numbers, and this is not as far away as it seems in my book. But what do I know? Let's go take a look at this and see how this plays out. All right, to reiterate, all those ports, 4 and 4, keep that in mind. And then, of course, across the bottom, we have the other USB ports. Now let's go take a look at the block diagram. The way this block diagram reads is from top to bottom, on the right for usable lanes, and on the left for total lanes. And we're going to focus on the lanes on this side. This is an easy count. So I'm going to zoom in on this just a little bit for PCI Express 5, and we'll touch on the other a little bit. All right, looking at the motherboard, and according to the motherboard layout, we have 2 slots, So with 2 slots on the motherboard, both of these are through the CPU. The interface is by 16 or by 8. That's on a switch. What that means is PCI Express 5.0 by 16. 16 lanes allocated for both slots. So one slot used by itself is by 16 electrically. Otherwise, those two 16-lane slots mechanically are each in a shared situation by 8. And this says by 0 by 8. So primary by 8 and secondary by 8 if you use both slots. So that's 16 lanes. Right here, another 4 lanes. And you'll see the number right there. 16 lanes, 4 lanes, and 4 lanes. So that's our 2024. Okay, according to AMD specs, that's our usable lanes on that right side, top down, allocating slots and storage. And we're going to get a little bit more into the USB 4 because that's kind of fascinating. And on the left side, where we need 4 more lanes for the total lanes as AMD accounts for that, and I'll show you what it says in the CPU in a minute, because I want to try to keep this tight and keep this as short as we can. We get the other 4 lanes where it gets not only in the weeds but down in a rabbit hole trying to account for that. I can account for 2 lanes, but I'm having difficulty accounting for 4 lanes. So suffice it to say, we're going to focus on the 24 lanes that are on the right side. Those other 4 lanes, I'm just going to say there's 4 lanes there. I'll talk about it a little bit, but I'm going to try to stay out of the rabbit hole. And I want us to get more into the USB because it affects how DisplayPort works. So now let's go take a look at the CPU first, and then we'll come back to this. The Ryzen 7000 desktop processor, to specifications, and that will take us down to the 4 processors we're looking at. And the one we're going to focus on is the AMD Ryzen 9 7950, where there's 16 cores. And we can look over here. All 4 of these have 2 GPU cores. So we'll go to the Ryzen 9 7950, and that gets us specifications. And the specifications we need are not here. We're going to go to the full specifications, and that will take us to what we're looking for. First item of business, we'll scroll down. Connectivity for USB-C, yes. Now this says native USB 10 gigabit ports 4, 5 gigabit ports 0. And this has native support for a USB 2 port 1. No SATA, relegated to the chipset, lower priority. Now these are native PCI Express 5 lanes, and these are CPU, total and usable. 28 total, 24 usable. We've counted the 24. And the additional usage of the PCI Express lanes from the motherboard, this is all 4 chipsets. And typically what we're seeing with these chipsets, based on the ones we've looked at, is we're seeing one manual generically for all of those 4 chipsets. And the difference being, if we, and I'll put up another screen for the chipset, is with those chipsets based on what's going on. And if you want everything this platform has to offer, it's on the AMD 670E. And the difference in the E versus the regular is the PCI Express 5. And all the other chipsets are going to have less resources as it relates to what we've just itemized and outlined. And to reiterate, the X670E chipset, which is a combination of 2 chips, a primary and a secondary, is made up of 2 of those lower-end chips. So what we don't know is, are those 2 chips the same? If we do a total, absolute total lane count that we come up with, we get 16 and 16. But consider the source and take that for a grain of salt. Everything here can change. What we're sharing with you is what we know for an overview. So if you want to decide, if you want to use this based on slots and storage for PCI Express resource allocations, whether this is something that's going to be your purpose-built computer for content creation and rendering. The next feature we need to look at beyond the usable lanes. We'll scroll down just a little bit further. And it's interesting, the processor has ECC support, but here in the notes, yes, but it requires motherboard support. So if you want ECC on one of these to use it as a workstation, that's something you'll want to look for. Then you'll need to look and verify with the RAM manufacturer what they have and what configurations are available. Right here, graphics capabilities, integrated, yes. The model, Radeon, right here, this is the feature. And this is a big deal. It was available, it was gone, and now it's back in a big way. USB-C DisplayPort alternate mode. That's a function of USB-C because USB-C can do 3 things: data, power, and DisplayPort alternate mode if it's supported. And because it's supported with a CPU, the question is, how's it routed? So we're going to look at the I/O panel, and we're going to look at, let's say, 3 possible ways to use video on this motherboard for internal connectors versus external connectors. How's that? Choose my words carefully. Now let's go back and take a look at the motherboard. Now that we know the specs and what we're working with on the CPU. The first M.2_1 connector, PCI Express 5, and we'll relate that to where that sits on the motherboard. Number 3, PCI Express 5 before. Now this is the Intel USB 4 controller Maple Ridge, which was Thunderbolt 4. So to reiterate, we're talking about USB 4, Thunderbolt 4. And that says PCI Express 5, 4 lanes. DisplayPort 1, DisplayPort 2. 2 ports. And over here, we have an HDMI port. And while we're at it, for total usable lanes, on the I/O panel, that says rear USB Generation 2, 2 ports. Now the nomenclature on that is specific for marketing, but from our standpoint for lane usage, that nomenclature is not finished. That should say Generation 2x1, 2 ports, implying, as it is, 1 port, 1 lane. And these ports are not related to these ports as far as resources, in case someone's wondering. But to reiterate, the ones on the right, all these allocate according to usable lanes. These allocate according to total lanes. But the lane count doesn't come out right. Because if we start talking about, and this would get not only in the weeds but in the rabbit hole, if we start talking about the SPI chips, both of these are low-level functions that are extremely important. We wouldn't have a computer without them, but not part of our discussion, so we're not going to get into that. We're just going to focus on how all this is set up. So this is M.2_1. Now, this is relevant for this discussion when we start talking about this fancy heatsink that's in this box. That's where it would go. If you want to get another fancy heatsink, you might be able to put one here, but I'm not sure you can use the fancy heatsink on that slot based on spacing. Now, this spacing looks tight. This spacing looks a little tighter. But to reiterate, it's for M.2_1, not for M.2_2. And if we look back over here at the layout, M.2_1, that's your only PCI Express 5 drive. So as this compares to some of the motherboards that have 3 slots and 4 M.2 drives, where you would have maybe 2 slots to the CPU and a 3rd slot to the CPU, or all 3 to the CPU, the 4 M.2 drives, which would be maybe 2 and 2, on this motherboard it's 1 and 3. Something to keep in mind as we're talking about speed, because PCI Express 5 is going to have heat, but PCI Express 4 still has heat as well, and that's where we went through the 14 M.2 NVMe heat sinks and we discovered that problem. I won't get into the specs for the speed, but I'll put it in the description because all that matters, so we can keep this tight. Okay, while we're at the CPU, right there's that heat sink I was telling you about. I'll tell you some more about it in a minute. It's pretty wicked. It looks like it may be available as a separate product. It has a separate listing, but we don't know yet. We'll see. But we'll talk some more about it. But that thing looks humongous. We want to look at the I/O panel. Now, starting from left to right, reading this top down, you've got your BIOS flashback button. You've got your clear CMOS button, which is really nice if you do something that doesn't like. And if you notice, there's one HDMI port. Now, what we don't have is a display port in or out. Why does that matter? Glad you asked that question. Okay, HDMI out, where do you think that video is coming from? It's coming from the internal GPU. So if there's no port for DisplayPort out, and there's only one HDMI port out, you're only getting video out of that one port until you get to the 2 Thunderbolt or USB 4 ports. That you could take your video card, put it in a slot, route video out of the video card, and route it back in on the motherboard to Thunderbolt, and then get video out of Thunderbolt from your video card. So you know what that means. Let's keep going. We're not done. You've got your Wi-Fi, which is the Intel Killer Wi-Fi. Now these Lightning gaming ports, ASRock has a separate document just about those. Those 2 ports, just suffice to say, are coming from the CPU. We'll go back and look in a minute. And you got your 2.5 gigabit Ethernet. You got your audio and your Sony Philips digital interface. And right here, these 4 ports. Now left to right, top first, 10 gigabit and a 5 gigabit USB 3 ports. On the bottom, those are 2 Thunderbolt ports. And over here on the right, we have a stack. That may be 4 USB ports, but top down, on the top, those are 2 5 gigabit ports, USB 3. And on the bottom, those are 2 10 gigabit ports, USB 3. The question is, how are they plumbed? Let's go take a look at the I/O panel. Now, the best documentation we've seen for an I/O panel for descriptions has got to be MSI. So as we're looking at the nomenclature on this, we've got 1 and 2, as this reads left to right, but I'm going to go top down, number 1 and 15. Number 1, to reiterate, is the BIOS flashback, and you can see the key here. I'm going to scroll down. Number 15 is the clear CMOS button. And then number 14, that's your Wi-Fi, your killer Wi-Fi. Number 13 is your HDMI out, and that's getting video from the internal GPU on the CPU. Here we have our 2.5 gigabit, also killer, also Intel, and I believe that's using 1 lane. That matters. We can look at the chipset. Number 12 are the A ports, and there's a note here for one of those with 4 stars. We're going to go look at that in a minute. I'm going to get through the panel. Those are your 2 Lightning ports. Those are out of the CPU. If we look right here, that's those 2 ports, which should be a lane each. And of course, to reiterate the audio, then from left right, top first, number 9 and number 7. Number 9 is a USB 3 port. Number 7 is also a USB 3 port. Now, there is a note which port we're talking about for number 7, USB 3 2_4. The port that we want to concern ourselves with is the USB 3 2_3 that has a note. And then of course down here on the bottom, number 10 and number 8. Number 10 is on the left. That's a USB 4 port, Thunderbolt, because it's the Intel chipset. And then number 8 is also a USB 4 port. So to reiterate right here, the HDMI port, that's where you're going to get video out. And if you're going to get internal video out of these Thunderbolt ports, which we're now calling and identified as USB 4, but that's where you're going to get video out of the internal video. In other words, there's no way to take your external GPU and route video out through your Thunderbolt. The only video you're going to get out of your Thunderbolt, because on this motherboard there's only 3 ways to get video out of the internal GPU. One HDMI, to reiterate, and those 2 Thunderbolt ports. To reiterate, no way to get external video routed into that to get it back out, because we don't have a DisplayPort in connector. Some motherboards do, this one doesn't, but this has a ton of other stuff. So like every motherboard, there's always give and take, and we have to do this overview to weigh these advantages and disadvantages and decide what works best for you. What works best for someone might not be best for someone else. It just depends. But we're here to show you your options. Okay, based on the block diagram, that should cover what's PCI Express 5. Now, the other 4 lanes, when we talk about absolute lanes, you got to remember you got a CPU that has 4 more lanes that are PCI Express 5 that are downgraded to PCI Express 4 that connect with that first chipset. Anything that goes through the first chipset has to connect with a CPU. You got a secondary chipset that has to connect, and anything through that secondary chipset has to go through the primary chipset before the primary chipset talks. Anything you're going to do, and we're going to get into some of the stuff about DAW, those 2 lightning ports which are on the CPU, because we don't do gaming, content creation. If you're going to use this as a digital audio interface, I would think because of latency, and that's what those ports are there for to address, you would want to put that digital audio interface up there on one of those 2 ports. That may be a consideration as you would want to use this for audio. So number 2 would be whatever next port you've got, and that's if you're using USB 3. The next port you would have through the CPU would be on your Thunderbolt if you're using something Thunderbolt. Now, remember the Thunderbolt USB 4 port can be USB-C because of the connector, 10 gigabit based on the spec. And you have another chipset that handles USB 20 gigabit down below. So to reiterate, through the CPU, 2 lightning ports, which are USB 3, and 2 Thunderbolt ports, USB 4 ports, that would be 10 gigabit USB-C. So if you're doing an audio interface that's got to have those kind of requirements, I'll give you some idea of where you want to plummet. Lowest latency, a little bit more latency, and a lot more latency as we go down the food chain, down the tree. Just want to point that out. Hope that helps. Now, let's look at the first chipset. Lanes on the left, this is what we get into when we talk about total lanes. So we're going to focus on the right, which makes this really easy to count. But as you can see, we're going to do some weird stuff here with the SATA. Okay, 4 lanes, and we're supposed to have 8 usable lanes on this chipset. So there's 4, 5, 6, 7, and 8. 8 lanes. One M.2, which is M2_2, which is this connector on the far right. Because that's going to be PCI Express 4, that might be a location based on proximity to heat and memory where you might want to put a better cooling solution. But to reiterate, I don't know if this one that goes here would work there as an additional, or if you have to use one of the ones like we've been looking at, which would be either the Acetylene or the JI Finscold. Hard to say, up for conjecture. And since you've got height, that's an option. Back to the chipset. To reiterate, one M.2 drive. Now, here's where we get interesting. On the ASM 1061, we've got a separate chipset. We actually have 2. 1 lane, 1 chipset, and it has a switch on it, which is a little bit strange because it affects the M.2_2 NVMe drive, which can be, as it says here, an NVMe or a SATA. Whether it's a SATA on that connector, we need to verify, or whether it's the shared lane, singular, on one of these ports down here. This has a switch for 1 port, which is kind of odd because that means 1 lane, 2 ports. And we're going to go verify that information another place in the motherboard where it talks about if you're booting or whatever, you want to run something off of the SATA drives, 4 on the motherboard chipset and the other 4 through the extra ASM chipsets. These 4 are going to be faster than these 4 for that reason, because instead of having 1 lane per port, in this case, you've got 1 lane for 2 ports, and you've got 1 lane that shares with that TOT M.2 drive, which is the one on the far right, M.2_2. A little bit weird kind of a setup, because to reiterate, you would think that would be 2 lanes, but it is what it is. I'm just pointing it out to share with you as a resource of a prioritization of devices. And I'm going to go through some more information with the slots as we identify this, because some people don't get the slot and storage things, but some people understand, for example, the question, can we add a quad card, which has 2 requirements that I'm going to come back to. But I want to explain it this way before I go to the next way. Everyone has their different light bulbs, and usually by doing it 3 different ways, it helps. Somebody gets the light bulb one where someone can get the light bulb on the other. So that's how the resources are allocated on this motherboard so far. And that gets our total lane count. The Wi-Fi 1 lane, and the wired internet 1 lane. And we could look up the chipset and it would verify that. As well as this ASM 1061, it would verify this information. To reiterate, 1 lane, 2 ports. Now, if we try to count those other 4 lanes, this is where we get in the weeds. There should be 4 lanes here. Now up here, this USB 20 gigabit and the 2x2 means that's a 20 gigabit port. That 2x2 on the motherboard also accounts for lane allocation. Here, because it's built onto the motherboard, it's a different kind of resource allocation, so it's 2 lanes. So always, like I said, consider the source. I'm not perfect, but I'm sharing with you what I know, and since you guys have been asking questions, and it's been racking my brain trying to figure out how these lane allocations are working, there's not a lot of information about this, so I had to do some digging. And this is the way this works. So anyway, to reiterate, there's supposed to be 4 lanes over there. And if you want to count those, 2 of those to that primary, which means all that other stuff on there should be using just 2 lanes to get the total 4. Try to do the count. For me, it doesn't work. And then you got 4 other lanes that have to connect the 2 chipsets together. Now, based on this primary chipset having 8 usable lanes, my guess is the primary chipset connects to the CPU with 4 lanes from the CPU. So the other 4 lanes that connect the top chipset with the secondary chipset must be coming from that primary chipset. So 8 lanes here usable and 12 lanes down here usable. We can account for the usable lanes, but to reiterate, accounting for these USB lanes, it's crazy. And I'm just sharing you with what I know, and the more I learn, the more I realize how little I know, and the more curious I become. I've never counted lanes for USB ports on a motherboard, but we are now because of the X670E and because you guys are asking questions about it. So as we learn more, we do more. It has Thunderbolt 4, USB 4, which is kind of a rebranded. So while I'm at this, I want to interject that based on what we know, we've talked about in other videos, I won't get into, that get in the weeds, this would be considered, based on the information, if we went and looked at Intel's chipset, that is PCI Express 3, 4 lanes, and if it was PCI Express 4, 4 lanes, then it would be a difference in USB 4 version 1 versus USB 4 version 2, and I'll stop at that. Based on what we've read about the new AS Media chipset that's coming out, that's not out yet. Those lanes are PCI Express 5. So that leaves a question, is it possible for that to go further? I don't know. I'm just telling you what we found for what we've been able to figure out. And that's a question I don't know, but I'm curious. Because that has the potential for being USB 4 version 2 based on the lanes, 4 lanes. PCI Express 3 versus PCI Express 4. So for an audio digital workstation, this might work for what you want to do. You'll be able to do your virtual instruments. You can have your primary system boot drive. This gets into disk management. Then you can have a place for your virtual instruments, which might be on that second drive because it would be PCI Express 4. Then you can use the other drives for which are PCI Express 4 to do your audio rendering. Same for your video scenario. That second drive might be your data drive, or it could be your scratch drive, depending on how you set up your configuration. So we've been asked the question before, how you do the drives. My suggestion is going to be 3 drives. To reiterate, a primary boot drive with the operating system and applications, a secondary drive that could be a render drive, a scratch drive, or an instrument drive, or a data drive, and then a third drive that could be whatever. Now, of those 3, those are all M.2 NVMe. A fourth drive would be the drive where you do your downloads. That would be the drive where you do your data, where you store lots of stuff. So that once you've rendered a video, if you're going to keep a copy of it, keep it over there because it's slower storage, but it's adequate. This machine can do what anybody wants, I think, for content creation, as the resources are available. But if you need more resources, that's going to be a problem, because I still haven't finished the stuff about the quad card. We're going to get into, because what are the 2 requirements for a quad card? Second time I've asked that. Let's look. All right, on the CPU, based on we have 2 slots, and based on what we know to be true about the lane allocations, if you put a quad card in there, you cannot put a video card in there, because the #1 requirement, you have to have 16 lanes electrically. If you put a video card in here, you would no longer have 16 lanes here, you'd have 8, because this is on a switch, so you divide 8 and 8. So to reiterate, if you put a quad card in here, then you've got to get video out of the onboard CPU, which would either come out through one of the USB 4 controllers, or it's going to have to come out of that HDMI port. So that means you could have 3 monitors on this system without a video card. So add-in card scenario number 1. Now, if we go look at the BIOS, we need to find out the number 2 requirement is bifurcation. There's 2 slots here. First question, does this slot support bifurcation? Yes. Does this slot support bifurcation? Based on the numbers where it says 0 by 8, don't know, don't think so. But there's not always real clarity looking at a block diagram about lane allocations. And some of you ask, how do you know, is there some way to look on a motherboard? Joey had asked that question because one of the motherboards he was looking at while we were doing an overview, he was doing a review and giving us some notes on that, separate video. Anyway, what we learned and think of, it was a question he asked, how do you know, to reiterate those lanes? GPU-Z is the best way. It'll click and it'll tell you, and it'll tell you what that 16-lane slot is using for the GPU, whether it's using 8 lanes or 16 lanes based on slot lane allocation for that second slot for whatever he's got plugged in. And that particular motherboard he was looking at had 2 M.2 drives on a dual M.2 NVMe adapter, which was, I believe, an MSI motherboard. That was amazing motherboard. But the way the resources were allocated, it was just, that was amazing. So as we look at the resources on this motherboard, let's go take a look at the BIOS, because if we don't have bifurcation, that's a deal breaker for a quad card. Let's look. Now this is the ASRock, and notice this says AMD X670B650 series. So kind of like others, this may be generic for the platform, AM5 platform. Now in the BIOS manual, we're going to go to PCI Express configuration. This gets us started, and I'm scrolling up to show you if you're going to use virtual machines, SVM mode, among many other settings in here that deal with that. The SR-IOV for devices, for virtualization. But the setting we want, and right here is what you're looking for. PCI Express graphics lane configuration. So you can do a search for lane configuration, and what you're going to find allows you to configure J10 slot PCI Express lanes. That slot's the primary slot, and the configuration options are auto, by 8x8, by 8 by 4 by 4, and full bifurcation. Now, for those that ask the question, what does bifurcation mean? Bifurcation is the ability to reallocate resources on a slot. There's other things about reallocating resources as it deals with other stuff on a BIOS, but as it relates to a quad card, bifurcation is the ability to fork or to split. So where we have 4 M.2 drives on a quad card, and each one has to have 4 lanes, that's the full bifurcation of 4 by 4. Now with the other combinations we've got, where 8 by 8, well, you'd see 2 drives. Or where you've got an 8 by 4 by 4, you'd see 3 drives. Won't get into more of that than it has to. But on that primary slot, that's where you would use it. Now, another question that will come up, what about a dual adapter? If you put a dual adapter in here, you have to put it in that primary slot, because near as we can tell, based on information in the BIOS, from the manual, whatever you see in the BIOS is different. So we're based on what we read. We're telling you what you're looking for. To reiterate, if you want to put a dual adapter on there, it has to be in that primary slot, because only the primary slot can fully bifurcate, and it has to be 4 by 4. If what else is left, because there's 8 lanes. And as near as we can tell, there's not a setting for that other slot to do a bifurcation of 4 by 4. So, first question, quad card, primary slot, yes, no GPU. Next part of that, a dual adapter, poor use of resource allocation, but it could be done, but it has to be done on the first slot. Now, second question, what about the video card? Put it in the primary slot. What do you do with the secondary slot? Well, that brings us back to the issue of a quad card. Quad cards are 2 types, BIOS bifurcated, which is what we're looking at, or a self-bifurcated card. Now, based on a self-bifurcated card that requires 8 lanes, no bifurcation necessary because it's self-bifurcated. It has a PLX chip that does a couple things really fast. It does a switching of lanes, uplink ports and downlink ports. And because it does that switching, the requirements for a self-bifurcated card, it's either got to be PCI Express 16 or PCI Express 8. The 2 cards that come to mind that could be put in an 8-lane slot, number 1 would be Glotrend Sky, and number 2 would probably be the Amphitech Squid. Now, the Glotrend Sky is a 4-drive card, to reiterate, but it works on 8 lanes because it's self-bifurcated. The Amphitech Squid can take 6 drives, nothing else like it. Buying either one of those is like either buying the motherboard, like buying the chipset all over again. So when you're looking at a consumer desktop motherboard and you're trying to add storage, because of the investment you've got to make in one of those cards Our contention is you're better off on a workstation because of the investment. It's just, there's no comparison. So of the other scenarios for that second slot would be a self-bifurcated card, or because of the best use of resources, something else that takes 8 lanes. That's a lot of USB-C ports. There are some cards that we've talked about that would work in that. Now, if you want to put a capture card in there, which a lot of you guys get into for content creation, my contention is still there's better ways to do that, and it's through a USB-C port. But if you want, first of all, you've got your 1080 capture cards, which take 2 lanes. Then you've got your 4K capture cards of the 2 consumer brands, which take 4 lanes. So you're using an 8-lane slot for a 4-lane card. Now, there are other capture cards that take 8 lanes if you get into that a little bit more professional. But if you're using one of those kind of cards, I think you'd be using a higher-end machine. I digress. Blackmagic has a device that works externally if you meet all the requirements for that device, that does a beautiful job through USB-C. And I think it's a better use of resources. So some options. That pretty much addresses what happens with a quad card. That pretty much addresses what you would do with your video card. And no, you're not taking a performance hit on your video card if it's in an 8-lane slot. You'll be fine. I wouldn't want to put it on a 4-lane slot, but some do, and I digress. Your other option would be whatever you want to put in that second slot, some kind of I/O add-in card. Could be a capture card, could be something else. But remember, if you use a 4-lane card, you lose 4 lanes. You want to optimize those 8 lanes. That's my opinion. Then the other option would be about Thunderbolt, which is built onto the board. So even though you only have 2 slots, those resources that would normally on a 3rd slot that we see on some motherboards is already allocated to Thunderbolt, which is kind of nice having Thunderbolt on there if you want it, if you need it. You know, it's like anything. If you don't need it, it don't matter. So what do you got left? And right now, the only PCI Express 5.0 add-in card that we're aware of has been announced by Gigabyte. We expect that's probably going to be a year off, but we'll have the link in the description. And cutting to the chase, this heatsink is included with this motherboard to be used on that primary slot, which is PCI Express 5. The documentation on this is a little bit slim. Hopefully they will expand. There's nothing under support, but the overview tells you about what we're looking at, what we've been needing, that they're addressing. Apparently there's going to be 5 different types: a Type 1, a Type 2, Type 3, Type 4, and Type 5. And this says Type 5 Taichi. Now if we look at the models of the X670 right here, E chipset, 3 motherboards are listed, and all these other motherboards are listed according to chipsets and according to size, which address the issue that some have asked about on the form factor for the width of the M.2 as well as the length from 22 millimeters to 25 millimeters. And according to this thing is 30 millimeters, which is big enough to cover it. But I don't know if that's going to be mighty tight in there. It may be like Joey pointed out with the backplane on his GPU because of the close proximity he had to the RAM, which here has more space. I wonder how that backplane on that GPU is going to work next to that heatsink. I don't know, I'm just pointing it out, something to be aware of. But the fact that this is a product that may be a separate product marketed, that we don't know either, because we've also seen listings, remember in the past, when let's say MSI had the dual adapters and the quad adapters, but they were always with the motherboard. Other vendors, including ASRock, have had a quad adapter that was available separately. So because ASRock is doing this, my curiosity, and I'm wondering, is ASRock going to make this available? Because if we get a chance to test some other M.2 NVMe heat sinks, that would be a reason to test PCI Express 5. So Joey, I know you're listening to this, and this may pique your interest as something else to look into. But we need some more options before I think we go down that path, because this is just one, to test that heatsink and see how effective it is compared to some of the other stuff we looked at, which would be the top 2 that I've already talked about. 3 questions, a quad card, those are the options. That's what the video is about. The second question about which X670E has 2 16-lane slots. Based on lane allocations, you're not going to see it because it's not possible. It is an impossible feat. If you've only got 24 usable lanes and you need 32 lanes, because 16 and 16 is 32, there's not 2 16-lane slots. If, however, you can accept that you've got 2 8-lane slots, then any one of them is going to work, and you're not going to take a performance hit. So those are things to consider. And then for the third, about how the USB ports are allocated and located on that back port, I hope we cover that to the degree that will help you to understand where your layout is. CPU lanes, chipset lanes, prioritization for latency, prioritization of where the ports are at and what you're going to get. The only other thing about Thunderbolt would be the video, and I think we pretty well covered that. So I want to thank you guys for watching. My name is Gil Boyd. This is Builder Buy. Love my subscribers. Look forward to seeing you next video. We're out.